It's my real pleasure to introduce Dr. Idalmis Santiesteban, who is a psychology lecturer and researcher at the University of Liverpool. She completed her PhD at Birkbeck College, University of London, under the supervision of Professor Geoff Bird. Following her PhD, she completed an ESRC Future Research Leaders Fellowship at the Psychology Department, University of Cambridge. She's now a lecturer in the Doctorate in the Clinical Psychology program at the University of Liverpool. Her research interests are social cognitive neuroscience and autism. The current work employs a mixed method approach and relates to issues around late diagnosis, autism in females, masking, mental health and well-being of autistic children and adults. Very welcome, Idalmis. Good morning.
Thank you very much. Actually, although my work, as Alvaro mentions, most recent work revolves around autism. The talk today is going to be about empathy from a social neuroscience perspective. So I'm going to share the screen. Okay. So yes, no need for a further introduction because Alvaro has already done so. In today's talk, actually, I would like to talk about, I was actually enjoying the debate, the previous talk and the debate afterwards relating concepts, because this is something, definitions and concept of empathy. This is something I'm very much going to talk about as well. In psychology, obviously from a psychological perspective, empathy is seen as a multifaceted construct. I will also be talking about the neural basis of empathy based on the most recent research that there is on the subject. There has been mentioning in the previous talk and in the discussion afterwards as the importance of self-other, taking into account the other when you talk about empathy. So I'll be talking about self-other processes and importantly about individual differences when it comes to empathy and empathic understanding. And finally, I will talk a little bit, just touch on the emerging field of artificial empathy and some preliminary research that is being going on AI in the setting of healthcare to improve empathy. The first thing I say, this is interesting because I just had exactly the same lines I was planning to tell you, which is that there are probably as many definitions of empathy as there are researchers in the field studying it. And we've just heard so many of those different views. But one thing that there is obviously, to be able to study empathy, there has to be some sort of consensus of what it is that we're actually referring to. So there is a general consensus that empathy involves the capacity to understand and share the emotional states of another. There is a consensus there. There is not so much as a disagreement in that respect. And why is it important? Well, empathy is considered to be fundamental to human social interactions. As theorists and empiricists alike have long noticed its role in fostering cooperative behavior. Evolutionary perspectives suggest that the capacity for empathy supports mutual aid and reduces individual conflicts, which in turn fosters social cohesion and also support mental well-being. As a social construct, the study of empathy has evolved considerably over the years, and it has roots, as we have just heard, from philosophy, but within the fields of psychology, there's also important studies of empathy from social psychology and from developmental psychologists who are more interested on the development of these affective kind of states from early on and how they evolve. More recently, empathy is a key area in the field of social neuroscience. And what social neuroscience does in terms of empathy, it examines the cognitive and the neural mechanisms underlying it. And it also links psychology with neuroscience to explore how we process emotions. So the field of social neuroscience is actually a relatively new field of research. And it's one that makes sense because on the one hand, social psychologists have been doing research and advancing theories for a very long time. And then with the advancement of neuroimaging methods and brain stimulation and brain imaging, etc., since the late 1990s and early 2000s, a large amount of data, neural data, has become available. As neuroscience tries to understand what the data means, they need the theories and the foundations of social psychology. So that's basically the origin of social neuroscience. There has been investigations of psychology from multiple perspectives. Again, we just heard in the previous talk. And often the definitions go from cognitive and affective dimensions. So cognitive empathy relates to understanding another's mental states, while affective empathy involves sharing the emotions of another. So there are foundational theories that shaped the study of empathy. Early theories like Hogan's, for example, in 1969, they focused their attention on a role-taking approach. They attempted to contextualize and measure empathy as a purely cognitive ability. The emphasis there was on the development of measuring tools up to this point, which then focus on the empathy accuracy. So that is the extent to which individuals can adopt another person's perspective, precisely. So there were controversies around that, because then there were other researchers that found that from the late 60s and early 70s, that these self-report measures of empathic accuracy did not actually correlate to physiological measurements. And there were physiological measurements like galvanic skin responses or heart rate. They didn't necessarily, when they were taking these measures when participants were presented with emotional stimuli, and they didn't necessarily correlate, how empathic a person would say that they are in a questionnaire compared to the actual more objective physiological measures. It was then the work of Mehrabian and Epstein in 1972 that introduced the affective dimension into the framework. They emphasized the emotional resonance with others, and thereby establishing empathy as having both intellectual and emotional elements. This kind of rudimentary concepts had then been developed since the 1980s by a psychologist called Davis, and he developed a multidimensional model of empathy. In fact, this is, the work from this time by Davis is the measures that they develop are still used nowadays as self-report measures of empathy. They incorporate both perspective taking, which is like the cognitive empathy side, and that is like, I know how you are feeling. And they also involve the empathic concern. I'm sad because you are sad. Although operationalizing empathy into this cognitive and affective mechanism can provide a very useful framework for researchers, some others have warned against the segregation of these factors and have highlighted how they overlap, so between the cognitive and the emotional side. The multidimensional model nature of empathy does not arise from a single neurobiological mechanism. Functional neuroimaging studies suggest that different elements of empathy corresponds to multiple interrelated yet distinct brain processes that are characterized by the simultaneous activation of brain regions. The evidence from this work comes mostly from studies on empathy for pain. Now, other negative emotions have also been explored, such as disgust, sadness, and fear. But it is mostly empathy for pain where the work has been focused. And an interesting discovery that had taken place since the late 90s was the discovery of the mirror neuron systems in the macaque brain. And that is a set of neurons in the ventral parietal cortex and the inferior parietal lobule that fire either when the monkey grabs an object or when the monkey observes an experimenter execute the same action. And this finding kind of has led many scholars to claim that this mirror neuron system forms the basis of social cognition. This is a view that remains highly contested today because the claims have been big. You know, the mirror neuron system has been attributed a key role not only in understanding others' actions, but also when inferring intentions and mental and affective states of others. In the empathy domain, the shared network hypothesis is an extension of the mirror neuron theory. It is based on findings that observing or imagining even another person in an emotional state activates the same neural network as is associated somatosensory responses as the first-hand experience of the same emotions. So in this diagram here that I'm showing on the left panel shows a brain activated when a person is experiencing pain, like themselves in the first person, and then activations of participants observing another person in pain, and they activated out, to a lesser degree, but they still activate the similar brain regions. And these similar brain regions seem to be the anterior insula, the anterior midcingulate cortex, and they are known together as the pain matrix. And they are divided into sensory discriminative and cognitive affective systems. So the sensory discriminative system is responsible for processing pain perception, including the intensity and location of the pain. And this system involves the lateral thalamus and the primary and secondary somatosensory cortices. Now, on the other hand, the anterior cingulate cortex and the insular cortex are more important for encoding the emotional and motivational aspects of pain. As I was saying earlier, most of the work in research for empathy in social neuroscience have focused on empathy for pain and negative emotions to a lesser extent, disgust and sad, and fear. However, only recently, empathy for positive affect is starting to emerge and sort of gain momentum. And in this work is now offering insights into the shared and distinct brain networks involved in empathy for both negative and negative and positive affect. For example, fMRI studies have revealed that empathy for both negative and positive affect commonly activate the medial and also medial prefrontal cortex. And these are brain regions that have previously been associated with thinking about the mental state of others, or as is known in psychology, theory of mind. So as well as this pain matrix network, there is also brain regions that have been associated with empathy because of the cognitive aspect of it. So, however, positive and negative empathy, there's also that differ in one crucial aspect, and that's the empathizer shares emotions with the target that are inherently of different balance. Therefore, as it would be expected, both types of empathy selectively engage regions associated with positive affect, like the ventromedial prefrontal cortex, the orbitofrontal cortex, and with negative affect, which is the anterior insula and the dorso-anterior cingulate cortex, respectively. I was mentioning the shared representation hypothesis. And this is a hypothesis that emerged obviously as a consequence of the discovery of the mirror neuron system. And the idea is that it works on the basis of simulation. So if I see someone being upset, then I also become upset. And the neural markers of these experiencing pain in the first person and observing it in others, activates similar brain regions. However, it is important to note that there has been challenges to this shared representation hypothesis. The initial evidence of this representation, shared representations, emerges from social neuroscience research, because obviously a lot of excitement among empathy researchers. And there's been a surge of fMRI studies using a variety of experimental designs. So these reports of overlapping brain activations during first-hand experiences of an affective state and vicarious observations of someone else in the same state have been considered as strong evidence in support of this shared representation hypothesis, which, as I mentioned, is grounded on simulation theory. So, however, the contributions of neuroimaging in the field of cognitive neuroscience cannot be underestimated, but it is not a flawless methodology. There are inherent limitations to neuroimaging techniques. Two of the critical ones should be considered when interpreting fMRI data in empathy research. And the first one stems from the hemodynamic response, the blood oxygen level dependent, or BOL signal, is an indirect measure or a proxy for brain activity. It reflects the brain's metabolic and vascular responses to neural activity rather than the activity itself. That's why we tend to say that fMRI gives us correlational data rather than causational data. And because of that, co-activations of brain areas during first-hand emotional experience and empathy do not necessarily mean that the same neural processes are taking place in the two conditions. This is like an interpretation that goes beyond of what the data is actually telling us. So the second limitation relates to spatial resolution. If you imagine that each fMRI voxel, the smallest unit of 3D space within the brain that the scanner can measure, ranges in size between 1 cubic millimeter to 27 cubic millimeter, depending on the scanner's resolution. So therefore, a voxel can contain anything between 100,000 and 2.7 million neurons, depending on its size. Thus, the BOL signal in fMRI represents the average activity across a large population of neurons, not individual neurons, which makes fMRI an inherently coarse-grained measurement of brain activity. And there are researchers like Lam and Majdansky, which point out the neural activation observed during both first-hand emotional experience and vicarious experiences of empathy could just represent different firing and interaction patterns under different conditions. Yet their overall metabolic activity could remain similar, which is what researchers see when they look at the imaging data. In addition to these methodological limitations, research on social cognition offers challenges to the shared representation hypothesis, because they show that empathy for others' emotions is not solely reliant on mirror neuron or neural mirroring, but also involves distinct cognitive processes that are very important for understanding self and other. So self and other distinction is an important mechanism that has to be taken into account when we try to understand what empathy is and what the actual neural representations are actually showing. It has been studied in the context of imitation inhibition, visual perspective taking, theory of mind, agency detection, emotion regulation, and obviously empathy. It's not just about sharing the emotions, but about distinguishing between self and others. And I'll give you a clear example in the clinical setting. Simple definitions like emotional contagion, like if I see you upset, I'm also upset, psychologists argue that are not necessarily a pure, an accurate definition of empathy. Imagine if in a clinical setting, a patient goes and let's say a nurse or a doctor attending to the patient actually feel the pain and the affective state of the patient to the same extent. If they do, and that kind of overlapping of self and other representations, affective representations in this case, remains, then the clinician will be unable to help the patient. There is an important distinction that has to be made, and the clinician at that point has to say, it is you, the patient, who is in pain, who is distressed, and I am here to help you. So that clear distinction between this is you and this is me is what actually allows to provide that care and to actually act empathically towards the patient. And that's why, self-order distinction is so important. But it's also studies from atypical populations that have shown that challenge this shared representation hypothesis. There's data showing, for example, that people with congenital insensitivity to pain, which is a rare genetic condition where the individual is unable to feel physical pain, these individuals still show activations in brain regions that are associated with pain, with observing pain in others, or empathy in the pain matrix, like the anterior medial cingulate cortex and the anterior insula, when they actually observe pains to others. So if they are not able to feel it firsthand, how is it that they can feel something, or the activation of these regions are there when they observe pain in somebody else? And another interesting finding is from studies of neurosensory synesthesia and alexithymia, which are alexithymia are individuals who are unable to, or have difficulties labeling and describing emotions. They still show empathy. And I'm aware of the time, so I better move on. So in terms of individual differences, this is one factor that we haven't taken into account, is that individual differences are very important when it comes to empathy. So there are factors including emotion regulation, cognitive abilities, and cultural backgrounds that have to be taken into account. There are studies, for example, that show that gender differences in empathy during development, where girls tend to be developing empathy at an earlier stage than boys. And also studies showing differences in empathy processing between adolescents and adults. And one of our own research that shows that autistic individuals exhibit typical affect sharing, the ability to share the emotional effect of another person, but they actually have difficulties in emotion identification. And this is an example of one of our studies in which if two people are rating the affective state of another person, we don't necessarily take into account the accuracy in which they rate the target, in this case, Anna, in this illustration. They don't necessarily have to be accurate, but it is about the extent to which what they think the person is feeling and what they're actually feeling are kind of closer together. So their actual own state is closer together with the person feeling the pain. Areas, I'm quickly going to just go into two areas of recent advancement in research of empathy in social neuroscience. And one is the use of hyperscanning, which is when two individuals are research, including two participants that are scanned at the same time, included in an fMRI using empathic paradigms. And these studies have shown that there are increased brain synchronization when individuals share painful experiences, and that positive empathy also engages interbrain connectivity between two participants. artificial intelligence, artificial empathy and artificial intelligence in healthcare is also a hot topic in social neuroscience. So AI-assisted emotion recognition in doctor-patient interaction. So there's been studies in which they look at training nursing students in empathic communication and using AI tools to analyze speech and facial expressions for detecting distress. However, there has been concerns raised about the ethical issues arising from using AI technologies. Questions like, can AI truly replicate human empathy? And the risk of emotional detachment in healthcare. In this image, the diagram that I'm showing here is an example of a study in which they had an AI bot responding answers on an online forum from patients, like medical questions, compared to answers that a doctor would have had actually given them to the people asking the questions. And this analysis rated by 3 clinicians that were not involved in the responses, I found that the responses from AI tended to be more empathic than the responses from the actual doctors, and they prefer the responses from the AI bot compared to the responses that an actual doctor provided. So, as a conclusion, there are takeaways from this talk: that empathy involves cognitive, affective, and neural processes. That self-order distinction is crucial for balanced empathic responses. That individual differences shape empathic experiences, and the use of AI and hyperscanning are promising, but require further exploration in this field of research. We still have open questions. So how can we enhance empathy in clinical and educational settings? And can AI develop deeper emotional intelligence? So this is it for my talks. Thank you very much, and I'll welcome any questions that you might have.